Hello everyone, welcome to Generative AI Learning series. In this section, we'll see what is MCP, Model Context Protocol, and how to create an MCP server using Python. This particular section is going to have multiple videos. This is the introductory video. Here, we'll see the overview of all the use cases we are trying to achieve using MCP client. Throughout this section, I'll be spending less time on theory. We will try to learn it by doing. So MCP is a standardized and lightweight protocol created by Anthropic to enable LLMs to seamlessly interact with external tools, data sources, and services. Here in our example, I'll be using Cloud Desktop, GitHub Copilot, and Python program as the MCP clients. And we'll see even one example using Postman and Playwright. We'll get into the Playwright use case. And all these clients are going to use MCP protocol to interact with these MCP servers. So we'll be creating two MCP servers using Python program. One is going to be a very simple to-do list. There we are going to have multiple functions to add task, list task, and complete task. And here when we give an instruction through these MCP clients like Cloud Desktop or GitHub Copilot to the MCP server, it will automatically add list or complete task in a JSON file. In our case, it is going to be a local JSON file. It can be even an external database or any other service. And second example is going to be a simple network automation use case where we are going to have an MCP server, network actions, and there we have run command, get interface, assign IP, delete, loopback, all these kind of functions available. And based on the user instruction to the MCP client, this will run the task on these routers. I have two routers, one is local and another is remote. If you see in the MCP clients, we are going to use these three clients. In the end, even we'll see how to create a very simple Python MCP client using MCP use. And LLM models for Cloud Desktop, we'll be using Cloud for Sonnet. And within GitHub Copilot, we can use Llama 3.3, GPT 4.1, or many other LLMs are supported here. Then within the Python script, we'll be using Llama 3.3. And the Postman use case is going to be very simple. We are going to use a pre-built MCP server called Playwright. Playwright MCP server helps to programmatically interact with browsers that is written using TypeScript language. It is a superset of JavaScript language. We don't have to bother about TypeScript language. It is a pre-built MCP server with single npm or npx command. We can install a Playwright server, and then we'll see how to interact with browser using Postman. Like open a browser session, then enter a text and search in Google. Now we'll see all these demos. First, I'll open Cloud Desktop. Okay, now if you see here, I have already added to-do manager with date, and if you look into VS Code, I already have to-do MCP server with date. So it will be triggering this particular MCP server. We'll see how to create all this. In this video, I'm just going to show overall demo. It will be adding all the tasks here. I'll go to Cloud Desktop, and here we can see we have add task, complete task, and list task. Here I'll ask what are the pending tasks in the to-do list. Enter. So it is saying that you don't have any pending task, and we can see even this file is empty. I'll add a task here. Add client meeting on 20th June. Enter. So it is saying that I have added the client meeting task for 20th June 2025. Now if you go here and check, it automatically added. So what it is doing in the backend, it is triggering this particular MCP server and adding the data. I'll add one more task here. Add tracking time on 21st June. Enter. So we can see here. Now, if you want to mark any particular task as completed, mark client meeting as completed. Enter. Now we can see here it has automatically updated completed to true. So this is this example to-do list. Now we'll see how to use to-do list from GitHub Copilot. Here I'll open Copilot. Now for this example, I'll be using another MCP server called to do MCP server simple. This does not have the date, and it will be adding data into this particular file. So here it is already saying that our to-do list is empty. I have asked what are the pending tasks. Now here I'll add a task, add trip to Wynad in to-do list. Enter. So we can see here it is adding the task. Same like this, I can add another, add bike ride to in to-do list. Enter. So it'll be keep on adding the task. Now even this same MCP server you can access from Copilot. Now we'll see how to use MCP inspect. MCP inspect will help you to debug your MCP server. We'll go through the documentation later. Now to run that particular server in inspect mode, I'll get into the directory cd MCP demo, then to-do list app. All these we'll see in detail later. Now I'm just quickly running through what we are trying to achieve. Here I'll give uv run MCP to do MCP server simple.py. Enter. Here we need to give uv run MCP dev. Enter. So now this is running in the port number 6274. I'll copy this. I'll go to the browser, paste this URL here, and it is running in stdio mode. Later we'll see what is event transport type, stdio and SSC. Stdio mainly we use for the local executions. Since the MCP server is running locally, I am using stdio. I'll click on connect, go to tools, list tools. Here we can see all the tools available, and later even we'll see what is tools, prompts and resources. If you want to list all the tasks, we can just run the tool. Here we can see trip to Wynad and bike ride to Uti. Now if you want to complete a particular task, we can give one, run the tool. So task 1 marked as completed. Now we'll check it in the VS Code. So it changed to true. Now if we try running the list task, so we can see this has completed and this is pending. This is a small example of how to use MCP inspect while developing. This is an optional tool. It is not mandatory. While developing, you can use this for debugging your code and to understand the behavior of your MCP server. Now we'll look into a very simple network automation use case. For that, I already have two devices in the inventory. Let me just show you that. Under device inventory, 0.103 is running locally, and this is a Cisco DevNet device. Credentials are added here, and this script is working as MCP server. And if you want to test the SSH connection, we'll give SSH admin @ 192.168.0.103, enter, give the password, and we'll check the interface details. These are the interfaces. Now, from GitHub Copilot, I have already added this particular MCP server in the Copilot. You can see here, this is the Playwright. Then, yeah, Network Device Controller. Here we have all these tools available, and it is even loading the inventory. So what I can do here, I'll give a message, get the interface status of R2. R2 is 0.103, enter. So it is triggering this particular MCP server. If I give continue, so it is showing all the interface details. If I want to add a loopback interface, I can give an instruction, assign IP address 200.1.1/30 on device R1. I'll give device R2 loopback 1002, enter. So it is calling this particular function. It is called tools in MCP server, and assign an IP address to specific interface on the network device. So it automatically creates this dictionary, and it even converting this /30 into the proper subnet mask. And if I give continue, so it'll be assigning IP to the device. Now we can verify that. I'll give show IP interface brief. So now we have this IP, and these are purely for learning MCP server. Never do these experiments with production devices. Though devices are local, this data is going to the LLM. I'm using GPT 4.1. If I want to change it, I can just change to Claude 3.5 or Llama. Llama I have already added here, and these are just purely for learning. Same like this, from the Cisco DevNet device, I'll give an instruction, show me only SNMP server specific config of R1 and explain me each line, enter. So you can see here, it is framing a command, show running config, include SNMP server. I'll give continue. And if I expand this, I'll be able to see all the SNMP server configuration of the device. So these are the SNMP configuration, and below that, it is even giving the explanation. Same thing you can even do with Cloud Desktop. I'll give get the interface status of R1, enter. And here I have already added the network device controller. So it is trying to connect to R1. Now in this device, we already have loopback interface. Now from the Claude desktop, I'll say delete loopback interface 1002 from R2. Enter. All these are some very simple Python functions which are available in this code. We'll go through all this later. And here, if you notice, there is a difference. Here it is saying I have attempted delete loopback 1002 from R2, but it is trying to give a commit command. The commit command is needed only for this R1 device, and these responses will change model to model. So Cloud Sonnet is thinking that I'm trying to connect to an iOS XR device. For XR device, we need to give commit, and here this knows the command no interface, but it is trying to give commit. Because of that, it is saying one particular message, but if you look into the device, it has already removed the interface. Now, so here we need to even specifically give that it is an iOS XE device. But I have noticed that in case of ChatGPT 4.1 or Llama, sometime it will work. So all these are some of the limitations with each LLM. So you need to understand that, and you need to fine tune your instructions to the LLM. Now we'll see how to use a Python client. Let me just cancel our inspect. I'll go to AI directory, and here I already have a UV environment, and I have already created a video on even how to use UV. Let me get into the AI directory. I'll give UV run 002 and then 02 MCP client. So here also I can give query. It is a very simple script where I'm using Llama 3.3 for interacting, and here I'll be using this client. It is a to-do list with date. So here I'll ask what are the pending tasks. Enter. So it is saying that trekking on June 21st. There is a task which is pending, and we can see that. So client meeting has completed. Trekking on June 21st is pending. Now we'll see how to trigger Playwright. Playwright will help you to programmatically interact with browsers. I'll give an instruction. Open a browser session. Go to google.com and search for AI latest news. Enter. So it is triggering run navigate to URL. I'll give continue. Now it will be triggering a browser session. Yeah. Now it is running the next task. So element is search box, and it is passing the text AI latest news. I'll give continue. So we can see here it automatically opened a browser and entered something in the Google search box. This is a very simple example. Similar way we can even use Postman. Let me just open Postman. So here also I have already added this server Playwright, and let me just go and close our previous browser session. So navigate to, I'll give google.com. run. So now it has opened google.com, and then browser type will give element search, or even we can give same like this, search box or search. Then ref is E44. Then I'll give AI latest news. Submit, I'll give true. Okay, we'll run it, and we are getting the response. These are some examples of how to use MCP servers. Now I'll summarize the use cases we have seen so far. So we have used Cloud Desktop, GitHub Copilot, and we interacted with the local MCP server written in Python language. One is to-do list, and in the to-do list, we were adding the task into a local JSON file. And in the network actions, we had an MCP server called Network Device Controller, and by passing instructions through MCP client, we were able to add loopback interface, delete the interfaces, then get the interface details. This we have seen. Then using Postman, how to trigger this Playwright MCP server and automate the browser actions. And even we have seen how to run a very basic Python MCP client. Now we'll quickly go through the documentation of MCP server. We'll go to the introduction. Here, MCP is an open protocol that standardizes how applications provide context to LLM. So this provides a standard interface for LLM, and in our case also it is same. We have used multiple MCP clients, and using MCP protocol we were interacting with our local Python servers and Playwright, a pre-built MCP server, and we have even tried automating the browser actions. And in our case, we have stored this into a local JSON file, and we interacted with network devices. MCP hosts are programs like Cloud Desktop, IDEs, AI tools, and all. Then MCP client is the protocol it uses for connecting to the server. Then MCP server is a lightweight program. In our case, it is a Python script. Then local data sources, we have seen all that. Now, if you go to the Python SDK, here they have given the instruction to install MCP and how to run a very simple server. All these we'll see in the upcoming tutorials. And I have already created a video on how to use UV. Either you can use UV or virtual env. If you want to learn about UV, you can watch that video. I'll add that video also in the description. Then under for server developers, they have given Cloud Desktop as an example. And here we can see MCP servers can provide three main types of capabilities. Resources will provide file-like data that can be read by clients. So using this, we can even pass files or any other resources to LLM. We have mainly focused on these tools. So this is functions that can be called by LLM. We have created some Python functions and we were triggering these functions. And prompts are pre-written templates that help users accomplish specific tasks. So this will help user to give some pre-written prompt to the LLM. These are very simple concepts. So in this section, we are focusing on tools. Then under inspector, we can see the documentation on inspector. We have seen a quick example of how to use inspector. We need to use UV, run MCP, dev, and the Python file. It will automatically run it in a particular port. You can just go to inspector and get the tools or resources and inspect your MCP server behavior. that is MCP inspector. So this will be mainly used for debugging your MCP server. Then under core architecture, we can see it is a client to server communication protocol. Later, even I'll create some videos on async and all. But in this demo, we are going to use very simple functions. Then under transport layer, so we can see the types. One is STDIO transport or HTTP with SSE transport. So throughout the demo, I was using STDIO transport because in our use case, the server is running locally. So you can see here, it is ideal for local processes. Later, we'll see this as well. Then here we can see some documentation on resources, prompts, and tools. So this expose data and content from your servers to LLM. So you can put file content, database records, API responses. For passing all these data, you can use resources. And prompts are to pass the reusable prompts to the LLM. So this will enable servers to define reusable prompt templates and workflows. This also we'll see later. Then tools enable LLMs to perform actions through your server. So you can go through all this documentation, and from the next tutorial, we will start writing code for building all these servers. I hope this video was helpful for you to understand the basics of MCP server. Thanks for watching. See you in the next video.